Today we're talking about regular polygons. You guys remember what a regular polygon was? Means all the sides and angles are equal. So, like, we don't have a hexagon area formula, but if it's a regular hexagon, there's kind of a trick. It turns out if you draw the center of the hexagon and then draw these out here like this, you can split it up into 6 congruent triangles. And do you guys know what this angle right here would have to be? Why is it 60? Well, it looks like it, but how do we know? Okay, what do all these angles have to add up to? 360, right? This one full circle makes 360. So how do I find just one of the angles? Divide by 6, which is the same as the number of sides, right? 360 divided by 6 is 60. So this does happen to be, now if it was like a pentagon or something, that, well, yeah, sloppy Joe, get out of here. If it was a pentagon, this angle would be 1/5 of 360. It's like 72 degrees. So it's messier, but yeah, in the case of a hexagon, it does make 60. And if we draw in the height down there, that'd be like a 30. So we get like a 30, 60, 90. Anyway, if you find the area of one of these triangles and multiply it by 6, the number of sides, you get the area of the hexagon. And that's kind of the trick. But they simplified the steps here. This height of one of the triangles, they actually call the apothem. Apothem. So it sounds like you're trying to say possum, but you get like a speech impediment or something. Apothem. And so this is a side. All the sides have to be equal for this to work. So the area of a regular polygon is 1/2 times the apothem times the perimeter. They simplified the steps down into that. How could we find the perimeter? Take the length of one side times the number of sides, right? Because it's a regular polygon, all the sides are the same. So the perimeter is just the number of sides times the length of each side. But anyway, yeah. So this is the formula. You do need to know that. Maybe you should back up for a second and review the special triangles a little bit. Okay, on a 45, 45, 90, what are the lengths of the sides and ratio of the sides? 1 to 1, square root of 2. On a 30, 60, 90, let me draw it differently. What's the ratio of the sides? Let's start with the short leg. Which one's square root of 3? Bottom. That's right. Okay, anyway, so that means like if this was actually 5 long, this would be 10 long, and this would be 5 square root of 3, as an example. Okay, anyways, back over here. Okay, a few definitions. They call each of these a central angle. So we found the central angle on the hexagon to be 60. This dotted line that's like the height of one of the triangles is called the apothem. I mentioned that. What else? A radius goes from the center to the edge. It's called the radius because if you drew a circumscribed circle, it's a little bit too wide, but this would be the radius of that circle. So, anyway, still a radius. The length of each of those. Bottom side, got it. Okay. On number 1, it says, is segment DH a radius of the regular polygon? Do you guys see DH over in the picture?
Yeah.
Is it a radius?
Yeah.
Yes. Not a trick question. How do we know it's a radius? Goes from center to a vertex. Remember those corner points were called vertices, vertex. Okay. Number 3, how many central angles are in that figure?
Is it 2?
No.
6?
No.
What's the central? Oh wait,
3?
I'm thinking of,
No.
Don't they meet at the middle?
I was doing 2.
Yeah, central angles are the angles in the center.
What is the central angle again?
We just any angle like that in the center?
Angles in the center, from the center of the... How many? 7. So the number of central angles matches the number of sides. Like angle BHA, it's a central angle. It's an angle from the center going out. Do you guys remember what a 7-sided polygon is called? Heptagon. So on 4, how could you find one of those central angles? Divide by 360 divided by the number of angles, right? It's split up into that many angles. Okay, on number 5, these are kind of easy. What is WX called? Not a trick question.
Segment?
It's a side.
Side.
Okay, number 7, what is angle XCY called? It's a what?
A central angle.
Yes, it's a central angle. Number 9, how do we find the measure of angle WCX? Okay, what do all those angles in the middle have to add up to? 360, because they make a full circle. So if we want to find just one of them, what do we have to do?
Divide by 6.
5.
Divide by 5 in this case.
Oh.
The number of central angles is 5, so 360 split up into 5. What's 360 divided by 5? Okay, I didn't really talk about number 10. So on number 10, if this is 72 degrees, how can I find one of these angles?
On number 10?
Mm-hmm.
Oh.
No. These are not, it's not an equilateral triangle, no.
Oh, you do.
Plus the 72 to 72, 72 doesn't add up to.
Would you do 180 minus, or 72 minus 180 and divide what you get
Set
into
it
2?
right the first time. 180 minus 72, yeah. Yes, because the radii have to be the same length, these two angles have to be the same. So 180 minus 72 gives you these two angles together, but then you split it in half to find just one of them. Okay, number 11 says find the pentagon's area if CM is 10. Okay, if CM is 10, what did I call the CM? The apothem. Okay, so apothem is 10. And it also says that WX is 11.8. Alright, do you guys remember the formula for area?
A equals 1/2 AP.
Apothem times perimeter. Okay, we know the apothem is 10, so that's going to go right there. But what's the perimeter?
11.8 times 5.
11.8 times 5. So 1/2 times 10, that's the same thing as divide by 2, right? 1/2 times. Anyway, 55 plus 4, so 1/2 times apothem times perimeter. I think this one's centimeters. So on 12, they give you the area, and you have to work backwards to find CM, to find the apothem. So you have to do some algebra, work it backwards. Put 125 in for A, 8.5 can help you find the perimeter. Put that in for P. Okay, anyway, 13. Sam wanted to find the measure of angle VWX. I guess we're using the same picture as before. So he divided 360 by 5 and got 72. But when he looked at the angle, he realized it had to be bigger than 90. Explain Sam's error. Okay, in the picture, angle VWX is like right there. And he did 360 divided by 5 to find it, because it's one of the 5 angles in the pentagon. So why, and he got 72, why did he get it wrong?
72 is for one of the angles.
Yeah, 72 is for one of the what?
One of the sides, I mean.
No.
The, what's it called?
Huh?
The central angles.
72 is a central angle. So how should he have, well, I'm not going to write that. How should he have found this angle? I just probably don't remember. Okay. Sam found a central angle instead of an interior. So he found one of these angles down here instead of one of the interior angles of the pentagon. Okay, that's the A answer, I guess. They wanted what he did wrong. So B, though, is we're actually supposed to find. There's 2 ways to do it. Okay. One way is we kind of talked about this like on number 9 or something, but remember we can find what these little angles are right in here, right? And if we just put two of those little angles together, that would add up to one of these angles. Okay, the other method goes back a couple chapters. How do we find what there's a formula to find what all the angles of a polygon add up to. Anybody remember?
180.
Okay, sides minus 2 times 180. That gives you all the angles of a polygon. So what if we want just one of the angles of the polygon?
5 by 5.
Divide by, the number of sides. In this case it is 5. So it's 5 minus 2, probably want to do that in your head, times 180 divided by 5. All right, 13. Oh, there's a C. Make a conjecture relating the measure of the interior angle in a regular polygon and central angle. So, darn it, I have to scroll all the way back down. Well, okay, we got, for the central angle it was 72, and then the interior angle is 108. So make a conjecture means kind of make an educated guess. What do you think's going to be true about the central angle related? How's it related to one of the interior?
To 180.
There, yes. What's the fancy way of saying that? They are supplementary. Number 15. Okay, so find the area. What's the formula again?
1/2 a p.
Yeah, 1/2 Potham perimeter. Short and sweet. But they don't usually give us the perimeter. We gotta find it ourselves. On 15, they give us the hypotenuse 9.6, but they don't give us the perimeter. How could we find the perimeter on 15? 14 times 5, which I believe is 70. So it's 1/2 times Potham, which they just gave us, times perimeter. 1/2 times a Potham times perimeter. You could in your head be like half of 70 is 35, so it's just 9.6 times 35. Make your life a little bit easier. But this one comes out as 336 square feet. $17. 18's got a little bit of a trick on it. Okay, 17, perimeter on 17. How many sides does 17 have?
8.
Is it 8? No,
7.
7. So the perimeter is going to be 26 times 7. So I'm gonna do 1/2 times the apothem, 27, times the perimeter, which is 26 times 7. So I didn't figure out the perimeter, I just kind of wrote it in there. 1/2 times the apothem times the perimeter. I think we'll go to 22. I didn't know. This has turned out easier than I thought it would be. How dare you. Remember, I took a few problems off yesterday. So. The math teacher giveth, and the math teacher taketh away.
What's the answer? Calculator.
2457. Okay, 19. You guys, I'll let you guys look at 18. You can figure it out. 19. The altitude is 21. Find the measure of the apothem of a regular triangle. Uh-oh.
190.
Engage brain. I don't know if I can draw that very well. So they drew the height in, they drew a radius in, okay. Maybe I just should draw it really big, that'd probably help. That's the height. This is the center. The center would be the same distance from each vertex. They drew an apothem over. They drew 2 radii. And they drew an apothem right there. Radius, radius. Okay. Yeah, the apothem is always going to be 90 degrees because it's like the height of one of these little triangles. This big vertical line is the height of the entire triangle, the big triangle. And, okay, the altitude is 21. So altitude means the height of the big triangle. Let's put it right there. So, and what are we supposed to find? Find the apothem. Okay. I just realized what we have to do. We have to figure out what one of these angles is right here. I didn't really draw it, but this would be another radius there. So what is just one of these angles if we're splitting, it's a triangle, we're splitting it into 3 central angles?
90.
No,
180?
no.
It's 1/3 of 360, but I don't know what that is.
Okay, yeah. We have 3 central angles. They add up to 360. We want one of them, 120. Okay, if this big angle is 120, what's like this angle right here gonna be? 60. So what kind of triangle do we have right here? 60, 30, 90. Oh shoot. Maybe that doesn't help. Because we only know the whole height, not just that part. No, denied. The radius plus the altitude is use a formula they gave us earlier.
No,
Oh,
no.
yeah, I don't know how they expect us to remember that. These the radii, you guys probably don't remember this, but back when we did like in-center and centroid, these radii are angle bisectors over here, like they split this in half. They meet at the in-center, and the in-center is like 1/3 of the way from the side to the vertex. So the apothem is only going to be 1/3 of the height. Or this is 2/3 of the way. But the apothem from here to here is going to be 1/3 of 21. So it's just 7 centimeters. Okay, for 20, I'm not going to do it, but it says each side is 2 squared of 3. Okay, if it's 2 squared of 3 from here to here, how long is it from just here to here? 1 squared of 3, or just square root of 3. Okay, then, remember we talked about this is 60, 30, 90, right? So you have to use your special triangle knowledge. Say if this is square root of 3, how long is the apothem? That's for 20. I'm not going to say it. 21. The radius is 12. Okay, so I'm going to get rid of these from the last problem, these numbers from the last problem. Okay. If the radius is 12, this will help you with 22. If the radius is 12, how do you go from hypotenuse to short leg on a 30, 60, 90? Divide by 2, right? So if this is 12, this is 6. So anyway, 6 yards. Actually, 20 is using a different ratio, so it's not the 2 to 1. All right. Okay, try the evens.